All right, guys, so we're going to take a look at what it looks like to multiply rational expressions. And I always like multiplying fractions because it's pretty straightforward. For example, if you have a over b times c over d, you're just going to multiply the top times the top, numerator times numerator, denominator times denominator. So it would just be ac over bd. Pretty straightforward. Now, let's say we had something that was the same in the numerator and the denominator that we were taking the product of. We could cancel those, and that's what we're going to talk about next. So let's start fresh here for a sec, and we'll do this problem. Let's say we wanted to do x squared over x squared minus 4 times x squared minus 5x plus 6 over x squared minus 3x. Now, I know that looks kind of complicated, but one thing that's really important for us to understand is that we don't have to distribute x squared through the entire polynomial on the right, and we don't have to multiply the two denominator binomials. What we're going to do here is we are going to factor everything so that we can cancel top to bottom. And then we're going to talk about restrictions because there are going to be a couple of restrictions on this, and I'll show you how to write those. Now, I can rewrite x squared, and let me switch colors here so that we can really see what's going on. I could rewrite x squared as x times x, and I can, or I don't have to, and you'll see why later. But let's factor x squared minus 4. Now, you might remember this right here is the difference of squares. So it's going to just be x plus 2 times x minus 2. And it's really important to be able to identify what type of factoring we're going to be doing. And I think it's just practice. Practice, practice, practice. And I hope that you've done your factoring tutorial already. Now, our top right, we would do x minus 3, x minus 2. Once again, hopefully you're getting pretty good at factoring by now. And the denominator on the right is just going to be a GCF because both of these contain an x. So we would do x times x minus 3. Now, what I'm going to do is top to bottom, any part on the top to any part on the bottom, I'm going to cancel. And one thing that I really like to do is I like to cancel them in the same direction so I know which ones went with which ones. So let's say x minus 3, I see it matches with x minus 3. Now both of those, they would just cancel and become 1 because anything over itself in a fraction is just 1. So we can just assume that that's not there. Now if we're left with nothing, we don't put a 0, we put a 1 to hold the place. X minus 2 and x minus 2 cancel. You see how I drew those in the same direction? It helps me stay organized. Then it looks like one of my x's will cancel with one of my x's. Now, if I hadn't written it as x times x, that would still be okay. Because I know that x squared over x would still cancel partially. And I think that's it. So when I rewrite it, it's going to be x over x plus 2. That's all that's left. And no, I cannot cancel those x's because you can only cancel stuff that multiplies. And right now, x is being added to 2 in that denominator. But what I need to do is I need to say some values that x cannot equal. And the reason that x can't equal the values is because we don't have the capability of dividing by 0. No one does. You can't divide by 0. So what we want to do is we want to check out every value of x in the denominator and what it could have been that would make our denominator 0. And we want to make sure that none of those are true. So all the way here, it's kind of like the zero product property, but we're looking for what it doesn't equal rather than what it does. So the one on the far left, if x was negative 2, then this whole denominator would be 0, and that'd be no good. Same thing here. If x was positive 2, that portion of the denominator would be 0, and then multiplied by everything would make the whole thing 0, and that's no good too. This one right here, it's just plain by itself, so 0 is a value that we can't have also. And this one right here would be 3, because 3 minus 3 makes 0. So my whole solution, it looks kind of long, but that's this right here, simplified version on the left, and then values that x cannot equal on the right.